In this lesson, we'll look at the quotient property of exponents. The rule says that if we have x to the m divided by x to the n, that is equal to x to the m minus n. So it kind of reminds you in a similar fashion to the product rule. When we were multiplying things with the same base, we added them, but when we're dividing things with the same base, we subtract their exponents. So let's look at how that looks in our first example, x to the fifth divided by x to the third. If you think about this, this would be like x times x times x times x times x, 5x's over 1, 2, 3x's, and you can start canceling things out. 1, 2, 3. That would leave you with x to the second on the top. The rule confirms that. The rule says x to the 5 minus 3 is x squared. So instead of writing out all the x's, especially when the numbers get larger, it's easier to use 5 minus 3 is 2. Now in our second example, what happens when we have a larger number in the denominator? You certainly are allowed to say x to the 2 minus 7 is x to the negative 5. The problem there is that you have a negative exponent, and we can't leave a negative exponent. So to address that negative exponent, we then have to do another step where we make the reciprocal, and that is 1 over x to the fifth. I think that's an extra step, and I think eventually most of you will get better at this, that you won't need to do that. I'll look at the original problem here and see I have a 2 and a 7. I'm going to set up my bar, and I'm going to say I have more x's on the bottom, kind of thinking back to the picture over here where we had the x's all drawn out. So I'm going to do 7 minus 2, so I get a positive number. I'm going to get positive 5, and they're going to end up where there were more originally. So 7 minus 2 is 5, so I know I have x to the fifth left on the bottom. The thing you have to remember is to put that 1 in the numerator. Okay, so for this example 3, we've got x's and y's and some coefficients here all divided. Go piece at a time. The coefficients, you can simplify that just like a fraction. So that's 1/3. We don't need to necessarily write the 1, but we'll leave it there for the moment. And now we've got x to the third over x to the first. So we subtract those and we get x to the second. There's more on top, so they go on top. For the y's, I'm going to do 8 minus 2. And since there's more on the bottom, y to the sixth will go on the bottom. And that's our answer. Fourth example, I see some negative exponents thrown in here as well. So my first step would be to get rid of the negative exponents. If you want to, you can maybe address the coefficients here at the same time. So that's 2/3. X to the second goes down. X to the negative 8 goes up. So we have x to the eighth up there, x to the second down there. Y to the fifth, I'm just going to leave there, and y to the third here. You could subtract them. For my money, I think it's easier to apply the negative property first, and now you have all your powers are positive before applying the quotient rule, but it's not mandatory. Now we can apply our quotient rule. We have 2/3, and on top we have x to the eighth minus x to the second, so that's x to the sixth up top, and y to the 5 minus 3 is 2. So 3 is the only thing left on the bottom, so 2x to the sixth, y to the second, all over 3. Example 5, let's address the negative powers and the coefficients. So 9 over 6 is 3 over 2. I'm just going to leave that as a to the 10th over a to the 4th for the moment. And this b to the third is going to come, negative 3 is going to come down to the bottom. So b to the second and b to the third are at the bottom. So we can simplify the last step in the a's. And we have 3 over 2. A to the 10 minus a to the 4 is, divided by a to the 4 is a to the 6th up top, because there's more of them, and b to the 5th on the bottom. Notice, you should always, in your final step, only have one of each variable. At this point in the stage, I had 2 a's and 2 b's. You should never have that in your final answer. So when your final answer is no negative exponents, your coefficients are reduced, and you only have one of each variable, you're most likely reduced. Okay. One more example. Again, I'm going to choose to get rid of negative exponents first. So this a to the negative 4 goes down, c to the negative 10 goes down, b to the negative 4 goes up, c to the negative 2 goes up. So on top, I'll have b to the second and b to the fourth coming up, and c to the second coming up. On the bottom, I'll have the a to the second that was there, now an a to the fourth. I'll have a c to the second was there, and a c to the 10th that came down. Now we're going to go ahead and apply the product rule within the numerator and denominator. So the numerator here is going to become b to the 6th, c to the 2nd, and the denominator here is going to be a to the 6th, c to the 12th. So now I see one a and one b, but I see two c's still. So those two c's need to be combined. 12 minus 2 is 10. It's going to be on the bottom. So b to the 6th on its own up top, a to the 6th on the bottom, c to the 10th on the bottom is our final answer.